Today, what artificial intelligence examples you see are actually machine learning. They are not really artificial intelligence. And when I talk about the difference between the two, the difference is a very subtle difference. Go back to your maths classes when you used to draw a graph and you would plot a line along those graphs or plot a curve around those graphs. When we started programming, and I'm sorry, I'm ancient and I can talk about starting programming more than 25 years back, we could specify what is the points on that curve or on the graph. We could give specific values, and based on those specific values, trigger the discussions. The best we could do at that time was change those specific values into ranges. What machine learning starts looking at, what happens if there's a slight deviation from that graph or a curve and still be able to give you a coherent response, a structured response. However, there is one critical limit. Machine learning will be bound by the information which the machine has been exposed to, and hence will work only within that data range or within the minor deviations across the data range. When we talk about artificial intelligence, things change very differently. How do they change? We are not talking within limits. What happens if one of the triggers or one of the inputs is outside that limit? Then what will end up happening is the machine has to take a rational decision. It's neither correct nor optimum, but it's a mix of where the balance could be defined between the correct decision and a feasible decision. So that is where artificial intelligence starts looking at the rationality of a decision. The artificial intelligence technically can also start looking at, is it the right parameters which are being provided? Are all the parameters or all the systems working correctly? And it can detect that also. So machine learning is actually a subset. Artificial intelligence is a huge environment onto that. And we are still experimenting, we are still evolving in terms of how AI will start impacting our lives in real terms. Statistics. Well, let's talk about it. Machine learning originated from computer departments of the various universities. Statistics originated from the maths departments. There is a key difference when we look at statistics, and sorry, today's session will involve a lot of statistics, which has been a very dry subject. I know a lot of people hate that subject, but this is core to machine learning. Statistics starts looking at how's the information distributed, to what extent can we model that information so that we can understand the differences of the data within that distribution. Machine learning, on the other hand, starts talking about, based on this data, what actions do I need to take? It's immaterial whether the data conforms to a straight line on a graph, conforms to a normal distribution or Poisson distribution. Yes, remember those words. Those were the words from the 11th, 12th, and the first year of engineering, which we used to hate. So that is what is the difference, key difference between machine learning and statistics. Statistics looks at the data, looks at understanding the data. Machine learning is focused more on, based on the inputs, based on the prior data, what action can I take, what action is a logical action. However, the entire base of machine learning depends on a lot of the statistical data. Data mining, data warehousing, how does it make a difference? Data mining focuses on to searching for specific data. Data warehousing focuses on to organizing the data. Machine learning, again, going back to the previous item which I was talking in terms of statistics, focuses on to what is the task based on the data which is provided. How do I execute that task? And these are some of the differences which need to be kept in mind. You will have a copy of this presentation. but do understand these are the common questions which come across, and hopefully by putting this out, I am at least thinning away a little bit of the fog around what is machine learning, how does it interact with artificial intelligence, is it statistics, is it data mining, is it data warehousing. Theory apart, let's look at how our life has been. Spam filters, whether you're using any public mail system, you're using your office mail system, do you understand how the spam filters have evolved over the years? I have been using spam filters fairly long and have seen that evolution. What does a spam filter work like? Different mails come in, they will be put through a filter, and depending on whether the filter passes, it comes to my inbox or it goes to my spam folder. How does it do that? Have you ever wondered on that? Early stages, we used to have what was based on, I could target, please don't send me mails from this particular domain or this particular mail ID. My spam filter will filter out all these items and push them to the spam folder. If by mistake some mail goes to the spam folder, I could say keep this as a safe ID. It'll bring it back to my inbox. That is what was the early stages of spam filter. Today, with the spam increasing, I probably end up getting more mails in my spam folder than in my inbox. It's a reality for me, and believe it or not, I appreciate those spam filters. How do these spam filters work? Well, every time I or somebody else triggers a mail as a spam, what ends up happening? The spam filter looks at, is this something which is unique to this customer? By unique, I mean I have identified that specific domain or a mail ID as a spam, then it's unique to me. Or is it spam in a generic sense without the definition of, without narrowing down onto which domain it's coming from? Then it starts looking at a few keywords. If I have started classifying mails as training and the words containing training, and I push tens of those mails into my spam folder, believe it or not, all mails containing training, chances are high, other than my safe list, will move into the spam folder. What do we typically do? It's not one individual. Other people are also pushing such mails into the spam. So they will look at, is there a sale notice? And it's been classified as a spam, it will move it to spam. Is there a notice in terms of cheap or a word cheap? It will push it to spam. It also today detects if there are spelling errors or grammatical errors and an abundance of spelling or grammatical errors in the mail body, in the mail subject, it will push it to spam. You can try this experiment for yourself. It's a simple experiment. But this is how the spam filter has learned from each one of us. So every time we push a mail into spam, we are teaching our filters how to do spam classification, which way it will go and where does it go into that spam classification. So that's a kind of a difference which starts making a lot of sense. And believe it or not, this particular machine learning environment has been around with us for quite a few years. So now let's get back to the definition. What is machine learning? Yes, it's a subset of artificial intelligence. It uses statistical techniques, but now comes the critical part. It gives computers the ability to learn. We do not explicitly program those computers. We just guide those computers. So what ends up happening? We are creating computers which will learn, which will evolve, and make life a little bit easier for us. Would they replace us? I'll come back to that question much later, but today itself, because that's a critical question which people always start getting worried about. Will these computers replace us? Also go back to the hype in terms of What are the news articles we've been reading? We are not skilled enough. Computers are ready to replace our current work. Well, somebody's got to still put up those computers, teach them how to learn, and put them across for other people to use. So our lives as technical people, as programmers, is definitely got a shift, but not an end. How's the learning imparted? Collect, organize, train, evaluate, refine. Go back to your school times. What would the writers of any book do? They would collect a lot of stories or collect a lot of formulae, approaches, put them in a book. Variety would come from different sources. Variety would also come from new techniques which would be evolving, whether it's mathematics, whether it's history. Remember, today is tomorrow's history. So even history books also evolve. English, new chapters come in. So all that is collecting all the data from the depth and the breadth. Organize it, clean it. Every story which came in our English book had a little bit of editing done on it. Physics, while we talk about the three laws of Newton's, we also had the interpretation attached to it. At times, that interpretation, that explanation would be a little bit wider, little bit broader, little bit more detailed, depending on which class you were getting exposed to onto those areas. That is what is meant by organizing it. Then comes a nice part. Train. Class teacher will train you. Same way we today train the computers. We take that data, we train the computers. Same as in classrooms. At the end of the chapter, there would be some questions which the class teacher would help us respond to. Computers also, they will be taught through that mode. Evaluate. Remember those hated exams and tests? Well, that is what is evaluation. What we did at stage 2 was segregated our data into two sets. One set of data, which was the larger set, we used to train the computers. A second set of data, which is the smaller set, we used to test the computer after it's been trained. That is when we do the evaluation. That is when we start looking at the tests. Based on the output, based on whether the computer cleared the test or we cleared the test or not in our classes, a retest might be there. And that is where we refine the model. That is where all those classes, extra classes would be held to train further. We would have defined or we would have identified different factors which had been earlier missed out in collecting the data. So that goes on in a cycle. But the steps are absolutely same. As we teach individuals, we teach computers. Same way. Is that the only way the computers are taught? No, not necessary. One of the ways which is there is the supervised. What I just talked about is a supervised way of learning, where we provide the data, we provide the factors to the computer within that data, and then we specify which is the correct response for that set of data. This is the supervised. Those were the classrooms. Then there were unsupervised ways. Nobody taught us as kids how to get into trouble. We did it well ourselves. We didn't require anybody else to tell us to get into trouble. Well, we use that unsupervised means also with machine learning. What do? We just provide the bulk of the data to the computers. There is no difference. There is absolutely no change. We have not specified which is the right answer, which is the wrong answer. What are the various factors the computer has to look at while factoring in that data? No. We let the computer figure it out. And that is what is contained within the programming given to the computer, how to evaluate different pieces of data and let it come up with the various correlations, various factors to decide next time I get this data, how should I proceed with it? Now, there is a critical part between supervised and unsupervised. Supervised, once trained, does not get into further learning. Unsupervised is where does the training end? Where does the reality start? There is no end. What is the reality goes back into teaching the computer further. Every input which is given, the output, whether it's accepted or not, goes back into teaching. And that is where it gets into my third model, which is the reinforcement model. Oh, incidentally, these are not the models which I have devised. These are the standard machine learning models. What I'm doing is actually culling that out and making it simplified for you. So after we have taught the computer, the next set of data does not come with whether it's right or wrong or what is the expected outcome. When the outcome comes, that is the time the computer gets equivalent of a scale on the knuckles of the hand, which hurts. So that's a negative reinforcement, or some kind of a positive reinforcement whenever the answer is positive and the computer has moved on to that. Now, these are the continuous learning modes which I was talking about. Spam, and what I was talking as an example, is an exact same model in terms of how these computers are also taught. So what we went through in classroom, supervised followed by reinforcement, is exactly how the computers are taught today. The only difference, the computers have a narrower focus. They focus onto one or two different challenges and not onto the uncertainty of life around us. Unsupervised is where the computers keep looking at different factors, keep looking at various other inputs of data. And in my opinion, unsupervised is an environment which will actually move into what I'm calling is the artificial intelligence. So that will be the stage which will move it from machine learning into artificial intelligence. A lot of work to be done beyond that, but that is the kind of environment. If I can also give a perspective, unsupervised, while we knew how to get into trouble, unsupervised is also like learning swimming. You dump somebody into the pool, let them figure out how to swim. Let them figure out which is the shallow where they can stand. Let them figure out how to breathe underwater. But that is exactly what is unsupervised. Very, very interesting topic comes up when we start talking machine learning and we start talking also around the neural networks. I'm getting a little bit more involved here in terms of what is machine learning, but this is where the kind of areas start coming in very differently. Some of you would have done some level of biology during school. We are talking about how human neurons work. One neuron gets a stimulus, feeds into the next neuron or a set of neurons. That is the kind of information which then gets channeled through multiple neurons till the time it hits various centers of our brain. A neural network is a replication of that same approach. One input comes in, it is then at the first stage looked at what is the interpretation of this input. Along with the raw input, the interpretation is then fed to the next layer. It could be filtered, it could be enhanced, it also has the raw data. Can you imagine a cascade of such systems where input is coming from an external source, then there's a series of these systems which actually are taking up those signals plus the knowledge from the previous stage to analyze further till the time it reaches a decision point and triggers an action. As part of this, each stage not only propagates its own understanding to the next stage, but it also factors that into its own learning. This is very similar to the matrix environment, the matrices which we studied, where modifiers are provided from outside. Then there's a cascade of matrices till the time we are able to solve a complex set of linear equations. This is exactly similar. Just to give you a perspective, hopefully most of you have used Google translators, shifting between one language to another language. The Google translator was actually designed as an unsupervised learning environment. It picked up information, it picked up knowledge, it had in between access to various dictionaries, so that was its own ability to pick up the information. And it also started getting into how to do voice activations with some inputs at that stage. Well, Google set up a 30-layer neural network. If you can imagine, these are 30 computers connected in cascades. Each cascade feeds in further information. The accuracy over a 5-year duration has increased by 3 times, not by 3%, by 3 times. And that's a fairly fast learning. If you can imagine, go back to your language learning. How long did it take you to pick up the nuances of the English language? We still keep evolving, keep learning. But bulk of our learning onto the language happened over a duration of 5 to 7 years, maybe 10 years. If you can imagine the accuracy of Google Translator, it actually went in quite strongly. It picked up very aggressively, but it had access to the net. It had access to a lot more information on the net. So while we are talking about Google, you'll keep hearing, because Google is one of the parties which has done a huge amount of work around machine learning. You type in a search, on what basis does Google throw up the search results? Why a specific order? Especially if I have typed in 5 words and those 5 words are occurring across 5,000 different websites. On what order should Google display those 5,000 websites, or 50 or 500, irrespective? Well, the Google search engine also picks up the clicks. So any of you who have worked in terms of optimizing the searches, you would be familiar with this technique. Different people running different searches. What is clicked as the most common item, how much time is spent on that website, gets tracked by Google. So next time when you run a search, remember the first page of that search is coming courtesy a lot of other people who have done similar or same searches. That is how Google knows how to order it. Is it foolproof? No, it can be spoofed. We have done it. There have been people who have been specialists at ensuring that a specific website starts coming out very early on in the searches, because based on the searches, that is a website which has been clicked very often, very frequently. And that is how you fool Google. But that is the Google's computer. Sooner or later, somebody will report it, and that report will also be picked up by the machine, and it will start downgrading the priority of that particular website. Fair enough? Now, let's start looking at where we have been using machine learning. And believe it or not, exposure is tremendous. You apply for a credit card, you apply for a loan, part of the searches will come in there. Even as far back as late 90s, I was exposed to systems which could detect fraud on credit card charges. It looks at the spending pattern of the individual. It looks at what are the kind of charges which are there. It looks at where this individual has been purchasing. And an incident, which was funny incident, happened to me. I bought a small item. I was in US. I bought a small item for something like $10. Charge it on the credit card. Still in the same store. The next purchase was $400 plus. Guess what? That transaction got flagged off as a suspected fraud transaction. Same store, one charge of $10, so somebody testing out the card. Second charge, which is a huge amount, was triggering a fraud. So at that time, it didn't tell me that it was a suspected fraud. What came on the table of the person who was running the transaction was, please call this number immediately. They called the bank number. I was asked to prove my identity on the phone, and only then that transaction was done. And I'm talking, this one was, if I'm not mistaken, 98 or 99. So from 90s, these systems have been in place. The fraud systems work on the basis of neural networks. Machine learning has been around 20 plus years. Did you ever imagine that? We've been talking about AI in thin air when stage one of AI, which is machine learning, has been around now long enough. Same thing with insurance. Insurance is another area which is very, very prone to fraud activities. And there are specific systems which start looking at, is this a potential fraud transaction? Anybody coming from capital markets, you would have heard the word algorithmic trading. Algorithmic trading runs onto machine learning. What have been the trades? Where is the potential? Split-second differences, it will trigger off certain transactions, certain trades. It does not wait for an individual's intervention. It will do it on its own. But that is a machine which has been explicitly programmed to run those kind of trades. Is that machine programmed to identify which kind of trades? No. It's been programmed to identify what is the kind of percentage game they need to play to run those algorithmic trades. Been around, and it's been around for easily around 10 to 15 years, algorithmic trading. Deep Blue. The blue mention brings the thought of IBM. Deep Blue was a special computer created by IBM to play chess against the chess masters. 96, and this is a very interesting phenomena which happened. In 96, the reigning world champion on chess was Garry Kasparov. First match in 1996, Kasparov won 3.5 to 2.5, 6-match series. Next year, minor change in the algorithms. And guess what? Kasparov lost to the Deep Blue computer. So computer had started trumping the world chess champion. And there's a controversy around this particular loss. It seems there was a bug in the software. What that bug did, it took a step which Kasparov could not figure out as to, is this a logical step from the computer, or is this a human intervention behind the computer which is triggering this step? He got so lost in that supposedly that he lost the series. This bug was cleaned out for the subsequent game, but for that particular game was a key game which Kasparov lost. Out of the 6 matches, 3 matches went to the decider, 3 were draws, 3 which went to the decider, 1 Kasparov won, 2 Deep Blue won. This was 1997. Since then, there have been more computers. Now, can you imagine a computer playing chess intelligently against the world champions and getting away with that? When this was not the first attempt in 96. IBM had been trying to design such a computer from early 90s. So if I can go back and revise my term, machine learning journey started more than 25 years back. Mail spam, I have already spoken around that. Medical diagnosis. CT scans are based on CT is computer tomography, even magnetic resonance, MRI scans. These are all scans which are driven a lot by statistical models. Today's systems go one step beyond. Not only do they give what has been scanned, but they also highlight the hot zones or the pain areas. They are giving first level diagnostics. Can they specify whether these first level diagnostics make sense, whether they are correct or not? That is, and what to prescribe for such diagnostics? No, that is left to the human realm because a lot more factors today come in. Going by my reading of science fiction, maybe another 30 years or so, we will reach a stage where when I consult with a doctor, the doctor is only an artificial intelligence machine. Today, they are providing assistance. They are providing assistance into a faster input. Some of that might not be correct. So that is why the human hand or the human interpretation is required around these areas. Web searches, I talked about that, how Google web search works. Netflix actually ran a complete campaign inviting people. How would you predict what is the next movie to be seen by any individual? That entire set of recommendations, whether it's from Netflix, whether it's from Google searches, or any of the other websites, are all machine learning driven. It starts looking at, when we get onto Amazon and Flipkart, at the bottom, it shows what are the other items I might purchase. Where are they coming from? Part of it, they are coming from based on my own purchases. Part of it is also coming from what other people who have purchased this product have also looked at after that. So they are combining multiple pieces of information and giving me the top 3 recommendations out of that. Self-drive vehicles. Yes, self-drive vehicles have a lot of self-learning which is going on. How the traffic conditions, how do those traffic conditions translate into actual time? So Google Maps has a lot of machine learning built into that. More importantly, when you take different roads, what are the conditions of the roads? It's not just the traffic, it's the condition of the road. And as a result, what is the travel time on those roads? What is the turning radiuses? And the turning radiuses are very well mathematically designed, but there's still refinement which goes on as part of self-learning. And there's such a range of machine learning opportunities which are coming our way, which actually we are exposed to in today's life without realizing all these inputs are coming from a specific machine. Scary? Not necessarily. It's something which is the evolution which is there. So while the world is evolving around us, how do we need to look at evolving? How do we need to look at changing ourselves? Reason. And this is, I'm getting back into a little bit of an anecdote. When I started programming, Unisys had a 4th generation language called Link. It didn't pick up too much. Why it didn't pick up too much? Because computers at that time did not have enough memory. We were trained to write very efficient code, which would leave the smallest possible footprint on the runtime memory or the RAM and also on the hard disk. At that time, we were working with, even on major computers, with 1 MB or 10 MB of RAM. We were forced to define very, very efficient code, write very, very efficient code. Today's .NET, Visual Basic are actually 4th generation languages by those standards. What they generate is a lot of machine code. Is that machine code efficient? No, not necessarily. But does it take anything to increase the RAM on a computer? RAM has become cheap. In 90s, we had a huge challenge when we got our first 100 MB actually it was not 100 MB, it was 512 MB Spark server into our data center. There was a tussle between us system managers whose production system is going to get that machine. Remember, it was 512 MB of RAM. Today, I have multiple of that RAM on my phone running into GBs. RAM has become meaningless, the quantum of that. So do I need to look at efficient coding? Not necessary. And that is where today the machine learning perspectives start coming into play. Computers have become a lot more proficient in terms of efficiency. They have become a lot more expansive in terms of the number of problems they can handle. What has happened? When we started writing code into .NET or Java, we forgot about writing code in COBOL. What is happening now? A lot of data analysis is going to be taken up under machine learning. So our skills now have to go beyond writing those programs which will do the analytics, which will do the pre-processing of the data, data cleansing, and move on to the next stage activities, which is trying to understand how do these machine learning environments work, trying to pick up these skills. Now, whether it's machine learning skills, whether it's data science skills, or some of the skills, because today these systems are not actually resident on a computer which is lying in my data center. These are cloud environments. Do I care on how much cloud environment I'm taking up? That is processing power which is available on tap. Yes, I will have to pay for it. And that is how our skills have to evolve. That is a critical part in terms of whether machines will replace us. If machines will not replace us. Machines will replace the work which we are doing today, which means our skills have to go beyond what the machine cannot do, which is teaching the machine how to learn. Our jobs, as they are today, are definitely under danger, but our roles in the IT industry are still ensured provided we evolve. So when we start talking about machine learning, I can identify two specific areas. One goes into data science, which starts looking at how to create some of the algorithms. This is like today writing machine drivers or embedded drivers or writing an operating system. What are the kind of variety of algorithms which can come up? The second is programming using a language called Python. Python uses some specific builds, which actually makes it very suitable for coding machine learning tasks. It's a self-evolving computer skill. So when I was actually doing research, you can go on to YouTube, start looking at what are the videos. There are videos which range from a few single-digit minutes to running into hours. I tested out some of these videos. If you go and watch some of these videos on machine learning, you'll suddenly start realizing where did my material, which I'm talking about today, came from. It came from a lot of those sources. The two videos which I liked really well, one was from Android Authority, second was from Google. There are multiple trainings across MOOCs, Coursera, Udemy, eax.org, and this is very commonly available. The only thing which is required from you is the willingness to evolve. No money is required. Time is definitely required, but you have to go at it and put your energy into that learning. One of the sites which I'm giving, and one of the sites, this is from Google, you can go to this particular website. You will have access to this entire set of slides. You can go to this website. It is a 25 course compilation by Google, spread over 15 hours of learning. And if I'm talking 15 hours of learning, let me put on my hat as head of learning and development. This should not take you more than 6 weeks, 2 hours to 3 hours every week. But this is where your journey can start onto machine learning. You can decide. This Google course is around machine learning, which is around Python. You can actually decide to go into data science, and data science also the courses are available. Some of the data science courses which I found useful are on edx.org. And let me mention, edx.org is an organization which is promoted by Harvard and MIT. The quality of courses there is extremely good. Try these. One step though. If you want to go down the path of machine learning, there is only one requirement. You need to love data. You need to enjoy working with the data. You need to get a sense for that information. And then this journey becomes far more rewarding.